This year, OFC and NFOEC every year reflects trends of technology based on what are the new needs are. And this year will be no different. We are looking at software-defined networking, data center application, cloud application. Although these technologies, they don't seem to look like they are fiber optics, but in fact, they need fiber optics or broadband transport to achieve their objectives. For example, interconnected data centers, dynamic networking. They are all part of software-defined networking. And in that case, we have, this is one of the hot topics this year. The other one is how to increase the bandwidth and capability and make our network more flexible. And that dynamic networking and is another topic for this year's conference. And there are other areas how to increase the bandwidth. For example, different modulation techniques, they are important. How to go beyond 100 gig. 100 gig, only a couple of years in OFC and NFOEC, we were talking about hot topics. And think about how fast this technology has moved. From 100 gig, now we are talking about 400 gig, and even now, terabit. And that shows how technology has evolved in OFC and NFOEC, and also reflects how quickly industry has adopted these technologies. So these are the hot topics in our conference this year. And not only that, we are also looking at things like backhauling, about Ethernet backhauling. Everywhere we see a lot of applications, they are becoming mobile applications, but they all need bandwidth. So one more area which we see growing in OFC and NFOEC involves Ethernet backhaul. And we will hear many talks, and there are short courses related to that one. So our audience will have all these information available to them.
There were a lot of papers on applications that were very good on looking at control plane. I mean, I think control plane through things like OpenFlow is beginning to evolve, and people are starting to look at really upgrading their networks with control planes. Before, it's been in the standards realm and it's been in some demos, but now it's really hitting the labs and the carriers, and so we saw some good papers that way. And in the access space, which is our other committee, we saw some papers, a lot of papers again on economics, on improving the economics of some of the access architectures. So that was really hot in NFOEC this year. There are panels also looking at different control architectures and the trade-offs, and there also have been some papers looking at the trade-offs between different potential control plane architectures, including OpenFlow, but not limited to. And so now I think a lot of the main interesting hot topic to me is people figuring out how to use the 100G with either OTN switches, some Ethernet worked, and control plane to try and actually control the bandwidth across those 100G and above pipes. So I think there was a lot of interesting papers on analysis and how to best use those 100G pipes that are now coming into fruition.
So one of the really nice things about OFC is you get to see the actual just cutting edge results from research groups around the world that are working on technologies that'll be part of systems into the future. So in terms of the subcommittees that I've kind of followed a little more closely, there's a lot of work on space division multiplexing and multi-core fibers, as well as just to pack more bits into a fiber, as well as the devices that have to go along with those fibers. So if you have a multi-core fiber, you need a multi-core amplifier. And so there's a trickle down of, you have the basic fiber that's being developed, which in turn drives a whole slew of new devices, and there's many sessions that will be devoted to these new devices where we're not just talking about amplifying a single core, but now we have to take care of many cores within a single fiber. Or the other approach that's pretty hot is mode division multiplexing. There's several papers and a lot of programming on that this year. And then there's always, it seems like from the device or the component standpoint, there's always just really cutting edge, impressive results when it comes to the latest generation of transmitters for alternative modulation formats, devices in terms of modulators like ring resonators and silicon photonic Mach-Zehnder devices, as well as receivers. I mean, so really, top to bottom, you can list any component that you need in an optical link, and OFC has the state of the art in terms of where that technology really reaches its limit on any given year. So in terms of one of the topics that comes up every year at OFC is integrated photonics. And there's really been several efforts or several camps of development. Silicon photonics has been an active topic for the last decade or so at worldwide research labs and universities and companies, and as well as just pushing the state of the art in 3.5 or indium phosphide integration. And both of those kinds of component technologies are well represented at OFC. We are organizing a rump session this time that will hopefully generate a lot of hopefully heated discussion, or at least impassioned discussion on both sides. And that rump session is really looking at the role of integrated silicon photonics, and whether it really is coming to the point where it needs to move out of the research lab and become a viable technology that can deliver on a lot of the promise that's been identified over the last years, or whether it's just kind of relegated to more of a research curiosity that's got substantial issues to being fully deployed, and it's maybe a few years out because of these somewhat overlooked issues that research papers don't necessarily highlight but are crucial to kind of pushing the technology into the marketplace, like packaging and cost and all those kind of mundane issues that can really prevent a technology from seeing the light of day.